Assalamualaikum and hi everyone. Today we are going to learn subtopic 2.3.3 curvature. So if you refer to your module, you may turn to page 149. Okay, page 149. So basically, curvature means the measure of how sharply a curve is. Okay. There are altogether 3 formulas to calculate the curvature. Curvature is denoted as kappa. Okay, this is the first formula of curvature. We have unit tangent vector. So the formula equals to magnitude of t prime t divided by magnitude of r prime t. And the second formula is called as the cross derivative formula. So we have the magnitude of r prime t cross product with r double prime t divided by magnitude of r prime t cubed. And the third formula is called as functional form of curvature. So we have magnitude of f double prime t divided by 1 plus f prime t squared to the power of 3 over 2. And the radius of curvature is denoted as rho. Rho is equivalent to 1 over curvature. So let's take a look at this slide. Alright, we have 2 diagrams here, A and B. So for a line, dt over ds equals to 0, means there is no curve. Okay, no curve. But for diagram B, the magnitude of dt over ds is large, where the curve is sharply bent. So yes, we have the curvature here. So now, the radius of curvature is equivalent to 1 over curvature. So this is the illustration of radius of curvature. Let us solve example number 1. First of all, we need to find the unit tangent vector. So for the first example, I'm going to use the first formula. Okay, so I'm going to use this formula. All right. Now we need to find the unit tangent vector. R prime t divided by magnitude of r prime t. So of course we need, first of all, we need to differentiate our r. So we have r prime t equals to, differentiate 5 sin t, we get 5 cos t. Differentiate 5 cos t, we get negative 5 sin t. Next, we need to find the magnitude of r prime t. So we have square root of 5 cos t squared plus negative 5 sin t squared. So we will have 25 cos squared t plus 25 sin squared t. So as we know, we can factorize the trigonometric expressions. So we have cos squared t plus sin squared t. And we know that this is equivalent to 1. So we have square root of 25 equals to 5. Okay, now let's substitute into the unit tangent vector formula. Thus, we have t equals to 1 over magnitude of r prime t. So 1 over 5 multiplied by the r prime t, we have 5 cos t negative 5 sin t. Okay. So we can simplify, we can cancel the coefficient here. Then we have unit tangent vector equals to cos t and negative sin t. Next, we need to find Next, we need to differentiate the unit tangent vector. So just now we have tt equals to cos t minus and negative sin t. So from here, we need to differentiate cos t. I rewrite this again. So t, just now we have equals to cos t negative sin t. So differentiate dt, we get negative sin t, and differentiate negative sin t, we get negative cos t. Next, we need to find the magnitude of t prime t. So we have square root of negative sin t squared plus negative cos t squared. So this is equivalent to 1. Okay, so therefore the curvature is equals to magnitude of t prime t divides by magnitude of r prime t. So just now we have magnitude of r prime t equals to 5. So we just substitute here, equals to 1 over 5. And the radius of curvature equals to rho is 1 over curvature, so 1 over 1 over 5 is equals to 5. Okay, that's it. So the curvature is 1 over 5 and the radius of curvature is 5. Done. Next, example 2. Find the curvature and the radius of curvature of the following curve at t equals to 3. For this question, I'm going to use the cross derivative formula. Okay, the second formula, cross derivative formula. Okay, now of course we need to differentiate our r. So differentiate 2t, we get 2. Differentiate t squared, we get 2t. Differentiate negative 1 over 3t cubed, we get negative t squared. And then next we need to find the r double prime t. So differentiate 2, we get 0. Differentiate 2t, we get 2. Differentiate negative t squared, we get negative 2t. Now, since we are given a specific values of t, we need to substitute t equals to 3 in our r prime and r double prime. So we have r prime 3 equals to 2. 2 times 3 is 6. And negative 3 squared should be negative 9. And then substitute t equals to 3 in r double prime t. We have r double prime 3 equals to 0, 2, and negative 2 times 3 is negative 6. Okay. Now, we have r. We need to find the cross product of r prime 3 with r double prime 3. So equals to this is I, j, and k. Don't forget, here we should alternately put positive, negative, and positive. So the first row should be R prime 3. So we have 2, 6, and negative 9. And then the second row should be R double prime 3. We have 0, 2, and negative 6. Okay, now we can solve this cross product. We have 6. Okay, first of all, we close the first column and we are now crossing the second and third column. So we have 6 times negative 6 minus 2 times negative 9. This is for I direction, minus, open the square bracket, we need to erase this. So we are now crossing the first and third column. So we have 2 times negative 6 minus 0 times negative 9, J. And then we have plus 2 times 2 minus 0 times 6. Equals to negative 18I, and then we have minus, so becomes plus 12J, and then we have the plus 2 times 2 plus 4K. Right, so I rewrite this again here. We need to find the magnitude of R prime 3 cross R double prime 3. So we have square root of negative 18 squared plus 12 squared plus 4 squared. So this is equivalent to square root of 484. So this is equals to 22. Okay, we also have R prime 3 equals to 2I plus 6J minus 9K, right? From here. Okay, from here. Right? 2I plus 6J minus 9K. So next we need to calculate the magnitude of R prime 3. So we have square root of 2 squared plus 6 squared plus negative 9 squared. We get square root of 121, so this is equivalent to 11. Okay, now we can substitute these values and these values into the formula. Thus, curvature is, okay, the second formula, at t equals to 3 is equals to magnitude of R prime 3 cross R double prime 3 magnitude divides by R prime 3 magnitude to the power of 3. So we have just now 22 divided by 11. So 22 divides by 11 to the power of 3. Therefore, the answer is 2 over 121. Okay, done. And the radius of curvature. And the radius curvature is equals to rho 1 over curvature, so 1 over 2 over 221, so we get 121 over 2. That's it, done. Okay, now let us do example number 3. For example number 3, I'm going to use the third formula, okay, the functional form formula, this formula. Okay, find the curvature of the parabola given by y equals to x minus 1 over 4x squared plus, at x equals to 2, okay. So, functional form of curvature. The formula is kappa equals to magnitude of f double prime t divides by 1 plus f prime t squared I will rewrite this again. 1 plus f prime t squared to the power of 3 over 2. Okay, so now first of all what we should do is we need to let x equals to t and y equals to fx. Thus, this formula can be rewritten as y double prime over 1 plus y prime squared to the power of 3 over 2. Okay, so now we have y equals to x minus 1 over 4x squared. So we need to find y prime. Differentiate x, we get 1. Differentiate 1 over 4x squared, we get minus 1 over 2x. And then we have y double prime equals to, differentiate 1, we get 0. Differentiate negative 1 over 2x, we get negative 1 over 2. So at x equals to 2, we have y prime equals to 1 minus 1 over 2 times 2, so we get 0. And then y double prime equals to negative 1 over 2. So therefore, the curvature at x equals to 2 is I rewrite the formula again. Equals to y double prime divides by 1 plus y prime squared to the power of 3/2. I'm using this formula. So this is equals to negative 1/2 so negative 1/2 should becomes positive 1/2 divides by 1 plus 0 squared to the power of 3/2. So we get 1/2. Actually, this magnitude of y double prime should be positive 1/2. Okay, because when we take the magnitude, then we ignore the negative sign. So we have this answer for this question. That's it, done. So guys, you may try all of these exercises, and the answers already given at the bottom of the slide. So that's all. Thank you. All the best.